Welcome to qnawire.
Here we have a cart with a wheel on it. The cart is moving to the right at a speed of 48 inches per second. The wheel has a radius of 10 inches. We want to determine the angular speed of the wheel such that the point A on top of the wheel will have various velocities, so negative 48 inches per second, 0, and 96 inches per second. So to find the angular speed needed here, we want to find omega, that is. We know that the velocity of A given the center of the wheel, which or with respect to the center of the wheel, which I'm just going to call O, will just be the radius of the wheel crossed with omega. Well, the radius of the wheel, it's just vertical at this point, so that's in the j hat direction. And omega is out of the page, so in the k hat direction. So this will just be r omega j cross k hat would be to the right, so that's in our I hat direction. And if we're working in inches here, which is what I've converted everything to, this would mean that this is simply 10 inches per sec, or 10 inches times omega in our I hat direction. So pretty simple. So we can calculate the angular speed of the wheel when that velocity A is negative 48 inches per second. Well, the velocity A will have to be the velocity of A given O plus the velocity of O, which will be moving at the cart's velocity, which is velocity C. So we want to then solve this for omega. So we have VA equals, everything is in the I hat direction, so I'll neglect that for now. We have R omega plus VC. In other words, omega would equal VA minus VC over R. Well, in this case, we have a negative 48 minus VC, which is 48, so that's negative 96 inches per second, divided by the radius, which is 10 inches. So this should give us an angular velocity then of 9.6 radians per second. Then they want the angular speed of the wheel. To get the angular speed of the wheel, n, we need to look at omega times 60 over 2 pi. And this would give us the number of revolutions per minute, is what they want the angular speed in. And in this case, using the 9.6 radians per second, we get 91.7 revolutions per minute. So that was for part A. So I'll highlight all the stuff in part A in red. For part B, we use VA equals 0. If VA equals 0, we find that we get about a 4.8, not 4.6 here, 4.8 radians per second, which would give us exactly about half of what we had here for the revolutions per minute, 54.8 revolutions per minute. And we note that that these would have to be in the counterclockwise direction in both cases here. So CCW, CCW. And then in the final case, we have 8 feet per second to the right. So now we're going to have, so we should have a negative sign in front of both of these, but in this next one, we'll end up with just a 4.8 radians per second. Which will then give us the same angular speed for 45.8 revolutions per minute, this time in the clockwise direction.